This is a walkthrough of the worksheet for Ms. Volkening's conceptual or honors physics class for the worksheet Friction 1. Okay, so this is find and fill in the missing values in the chart below. So it says friction force, lowercase f, we've got the coefficient of friction mu, and the normal force n. Notice it's a bold n because it's a vector. Okay, so how do we find this? Well, the equation for a frictional force is mu times the normal force. Okay, so all we need to do is use this equation to fill in the blanks. So that's easy enough when I'm looking for friction. Okay, for instance, I want this one here, then I'm going to do 0.4 times 200. Okay, put that in the calculator and you get 80, and it's a force, so that's newtons. Okay, you just use this equation over and over again for all of the ones where you're finding friction. So that would be, let's see if I can do a highlight map. Okay, that would be like this one and this one and this one. Okay, but then we want the other columns. So let's look at the other columns. Use a different color, about pink. Pink is fun. Okay, so this one we want the coefficient of friction. Well, I'm going to use the same equation, but I want to solve it for the thing I'm looking for. I'm looking for the coefficient of friction, which is this thing. This is a mu, by the way. Mu, M-U. It's a Greek letter. It looks like a U with a tail off the front, but it means a whole letter by itself. So make sure you don't write an M and you don't write a U. It's a mu. Tail up, swish, U. Okay. I want mu, so I'm going to get it by itself by dividing both sides by the normal force, in which case mu equals the frictional force divided by the normal force. Notice these are both forces, both in newtons, so that means the newtons are going to cancel, and so mu is actually unitless. It's just a number. Okay, so let's do the first one where that's necessary. We've got friction force of 250 newtons, and then normal force of 500. Okay, 250 over 500 is 1/2. Okay, so this would be 1/2, or 0.5 if you prefer. 0.5. That's okay too. You're going to use that for every time you want the coefficient of friction. So that'd be here and here and here. Okay. Then we want the normal force. Normal force, how about blue? Blue is fun. Same equation, but solve for the normal force. So that means dividing both sides by mu. And so the normal force ends up being the frictional force divided by mu. Okay, so the first one we need that on is this one. So let's go ahead and do that. I get 70 over 0.7. Now be careful. I've had a lot of students that are like, oh, that's easy, I can do it in my head, and they'll put down like 10. 10 would be if it was 70 divided by 7. Okay, with the 0.7 there, you're dividing by something less than 1, so we should get an answer that's bigger than the numerator. We should get something bigger than 70. And in fact, we get 100. 100, and it's newtons because, because normal force is a force. Okay, so you're going to do that wherever, wherever it asks for the normal force. This one, and this one. All right, let's go look at the back. All right, on the back it says a box of mass 4 kilograms is at rest on a level surface. That level is important, by the way. That means, well, I'll get to what that means. The coefficient of kinetic friction is mu k equals 0.2, and the coefficient of static friction is mu s equals 0.5. So right here I have to make a little explanation, because if you're watching this video, it probably means you missed class. And that probably means you don't know what the kinetic and the static, what's the difference? Well, turns out there's two different kinds of friction. You've got the kind where let's see, we have two. Here's oh wow, no, that wasn't straight at all. Okay, try that again. Here's a floor, nice level floor. We got two kinds of friction. You've got the kind where you're trying to push on a box. Okay, so you're applying a force, but it's just not going anywhere. You ever try and move like a refrigerator or something, and you're pushing and it's just not doing anything? That's because static friction is fighting you. Of course, we still have normal force and gravity. Okay, but basically, if you're pushing and it's not moving, that's because the that's because the static frictional force and the force you're trying to push are exactly the same. And so so the net force is 0, and so it's not going anywhere. It's not accelerating. Friction can also be when that box is already sliding. It's moving. In that case, the kinetic friction is always in the direction opposite from the movement. There could be other things going on. Okay, we still have gravity and normal force, for instance. I could be pushing on this. I could be pushing right. I could be pushing left. It doesn't really matter because the friction always opposes the direction of motion. Okay, but these are two different kinds of friction, and so they have you use two different numbers for the coefficient of friction. Normally, kinetic friction is less than static friction. See, static friction is 0.5 and kinetic is 0.2. That's why when you're pushing and you're pushing and you're pushing and you're trying to make it move, there's a point where you push at the maximum force of the static friction, and it's like you're breaking it. And once you've broken it and the box is moving, you drop down into kinetic friction, which is less, which is why it seems easier to push once it's moving and keep it moving than it was to get it started in the first place. Now, static friction, actually we're going to get to that. Let's just do the problems. Okay, what is the normal force? Here's where that level thing was really important. It's on a level surface. As long as it's on a level surface, the normal force and gravity are going to cancel each other out. So they'll just be the same number. That's as long as we're on a level surface and we're not trying to pull up or push down on it. It's just sitting there or something. It's at rest. Okay? So that means the normal force would just be equal to the force of gravity, which is mass times gravity, which in this case is 4 times 10 meters per second squared. So I get 40 newtons. Okay? Now it says, what is the maximum force you could push on this box and have it remain at rest? Basically, what they're saying is, what's the maximum force you could push where the frictional force would still fight you? So we're looking for the maximum static friction allowed. Well, the maximum static friction, which I like this because I think it sounds really hilarious. FS max looks like FS smax. I don't know. I'm silly. It's that equation from the last page, mu times the normal force, where this is the coefficient of static friction. Okay, so in this case, that is, what is that, 0.5? And we just found the normal force, which was 40. So 0.5 times 40 is 20 newtons. Okay, so that's that. Okay, let's say you push too hard. Okay, so more than 20 newtons, and the box moves to the right. In which direction does the force of friction act on the box? Oh, I'm missing a question mark. Look at that. Whee! I can fix it. Love this program. Anyway, so now it's moving to the right, just like my picture. It doesn't matter what else you're doing. The friction force is always going to oppose that. So if it's moving to the right, friction is to the left. Boom. Okay. How hard do you have to continue pushing to keep the box at a constant velocity? Okay. So here's the thing. As long as this box is moving, the kinetic friction is the same number. It doesn't matter how fast it goes. It doesn't matter how slow it goes. It doesn't matter what else is going on. It's always this number. Same equation as before, but now coefficient of kinetic friction. Okay. In this case, that's 0.2. The normal force is still 40. So what I have is, what is it? That's 8. That's 8 newtons. Okay. So what I have here is, this is 8 newtons. Now, if I want this box to move at a constant velocity, I need the net force to be 0. Because if it's a constant velocity, then acceleration is 0. So the net force needs to be 0. So right now in the picture, like these cancel out, but I've got this -8, this 8 to the left over here that's totally messing me up. That means I must push 8 newtons to the right to cancel it out and have a net force of 0. So how hard do I have to continue pushing to keep the box at a constant velocity? Well, I need to push exactly as hard as friction is fighting me, so that would be 8 newtons. That's it.